Hello everyone. So today we are going to do our next lecture, which is groundwater storage properties, and we are also will discuss about aquifers. So this is sources of water part 3. Okay. So let's see what we have seen till now. So in previous lecture we saw that what's porosity. So this is the thing that we completed. What's permeability? We know that. We also know what's the difference between porosity and permeability. And we know what's hydraulic conductivity. We know what's Darcy's law. So these things we have discussed in previous lecture. And now in today's lecture, what we are going to do is we will be studying what specific yield, what specific retention, and what is aquifer, what's the types of aquifer, what are Aquitards, Aquiclude, Aquifuge, what's the difference between them. So we will be discussing, we will be getting overall what's like a simple idea of what is a uh, storing management of water underground, how it is stored, how can we take it out, how much can we take it out, and how much will be retained there depending on porosity or any other thing. What is aquifer? I mean the storage thing of the water inside ground. So like this we'll be discussing today's topics. So very first thing, uh, we'll start with by imagining a wet sponge. So for example, if we have a sponge, simple dry sponge, if we take it, what and if we pour it into water, it will be fully drenched into water, right? And it will like if we put it up, it will just the water will drip out of the sponge, right? And by some like after some time the dripping will stop, but the water will still be there in the pores of the sponge, right? And if we if we just simply squeeze the sponge, what will happen after that? The water will come out, more water will come out. That means we are putting energy. First thing, if we are just simply hanging it, the water is coming due to the gravity, it was coming out. But then if we just put some energy, the water will come out. That means if we apply more energy, if we apply more effort, we will get water from there. And with that, there will also be some amount of water that will be present in the sponge even after you put more energy and you squeeze it, right? So that water which is retained into the sponge is what we called as retained water, right? It will not come even after you apply energy. So this is in retained form. So same as the sponge, the soil medium also works. That means in soil also water will come out due to gravity. Water will we will take water even due to the due to our efforts are and putting more energy, and some water will always remain to the pores which we will not be able to take out. So this is how the wet analogy sponge the wet sponge analogy work in the case of soil. So let's move. So with this, what we have learned about something, we can take it out, something will be retained there. So the thing that is taken out is known as specific yield or yield of that ground, that how much is coming out. So what specific yield? It's simply like we will denote it by YS, specific yield. So YS is the amount of water that was drained by gravity. So if I put amount of water, it was drained out, right? So it was drained by gravity divided by the total amount of medium in which it was drained, right? So the amount of medium. So amount of medium drained. So simply if I put it into the amount is what? Amount is simply volume, right? So it's the volume of water that came out and divided by total volume of the medium from which it came out. So if we want to make it into percentage, we will multiply it by 100 and we'll get it into percentage, right? So this is what specific yield is. Now we talk about what was retained even after it came by due to gravity. So the retained thing was specific retention, and we denote it by YR. Okay, so if I want to define it, it's simply the ratio of the amount of water which was retained against gravity. So it is amount of water retained against gravity divided by amount of medium drained. Okay, so the volume which was retained, we can denote it by VR. It was retained, and total volume is V. If we multiply it by 100, we get it into percentage. So this is what specific retention, YR. Okay, and if this is not VW, it's water drained, right? So water drained is WD, VD, let's say. Okay, this is VD. Now we want to know the relationship between YS and YR. That if there is any relationship, can we calculate that? So if we do what? YS plus YR, simply just do it. And by the definition, it is YS is VD upon V and YR is VR upon V. Okay, and if I take LCM, we get VD plus VR. So now just think about it. VD and VR, volume drained and volume retained. This both together makes the volume of void of the soil, right? So this is the how much the pores are there, the voids are there. So VD and VR is nothing but it's the total volume of void, right? So in combination it makes VW upon V. Okay, VW upon V. Now just let's just multiply it by volume of void, volume, this is volume of water. Uh, yeah, I just did a mistake. VD and VR is what? It's the water, right? So volume of volume drained and volume retained is nothing but total volume of water there, not the total volume of void. In void, air can also be there, right? So total volume of water which is there is volume drained and volume retained. So it is volume of water. Now let's multiply it with volume of void on the numerator and denominator. So the total volume of void, if I multiply, so volume of void now, uh, now if I take volume of water to volume of void, what does it become? It becomes saturation, right? And if I take volume of void to the total volume, it becomes porosity. So simply now I can write that it's nothing but Ys plus Yr is nothing but N into S. And if this is one relation, okay, and if in underground the water is fully saturated, the medium is fully saturated, we call it fully saturated, right? That means there is no void of no volume of air. So the if so here S becomes 1 if it is fully saturated. That means 100% saturation means 1. So simply for fully saturated, and most of the cases underground, this is fully saturated only, then only you are taking water out from there. So it's fully saturated mostly. And if it is not, we have to multiply by S. So Ys plus Yr is nothing but simply N. So specific yield plus specific retention gives out porosity. So this is a very important relation. Alright, so this is how we learned what's specific heat, what's specific retention, and then what is the relationship between them. Now let's move on to numerical. Let's study one numerical. So let's say we have a surface. Let's say we have a surface. This is something with the area of 200 hectare. Okay. Now in this, I'm just taking this much this is something volume. Okay. So in this, uh, the water was at this level initially. It was at 20 meters. But we did some borehole, and from this we took some water. So it is VD. It was drained out. It will go, obviously it will go till here, and we have drained it out. So after that the volume, the water table drops down and it goes to 27 meter. And we have given that porosity of this soil is 0.4 and specific retention is 0.15. Now we need to calculate what is VD, how much volume we took out. Okay, so these type of questions can come into your GATE exam or any other exam which you are preparing. Any competitive questions will have the questions from these only. Okay, now let's start. So you have been given N and you have been given YR. We just now studied a relation which says that Ys plus Yr is nothing but N. We are just like, let's say it's for fully saturated, so S is equal to 1. So it's for fully saturated. So now this becomes Ys is equal to n minus yr, and n is 0.4 and yr is 0.15. So it comes out as 0.4 minus 0.15, 0.25, 0.25. So it's nothing but it's Ys. Okay. And now we know with the formula that Ys, that means specific yield, is nothing but volume drained upon total volume, right? So from this, can I say that Vd is Ys into V? Yeah. And I have just calculated what's Ys, 0.25. Can I have the total volume? How can I calculate the total volume? So how much volume of water that was actually present into the ground? And that in what, in this change, that means initially it was 20 meters and then it dropped out to 27 meters. So how much volume that it in vertical, how much length it dropped out? It dropped out 27 minus 20, that means 7 meters it came down. This is 7, right? Now 7 meters it came down, and in area wise it's 200 hectare. So what was the total amount of water present into the soil? It was 7. B is nothing but 7 meter into 200 hectare, right? It was total volume that was present. So 7 into 200, it came as 1400 hectare meter. Yeah. Now, if I multiply it with this, Vd is nothing but it's the amount of water that came out, that drained out. It's not the total volume of water that will come out. Volume of water in the soil will be more. And out of that, what drained out is Vd. So Vd drained out is 0.25. That means only 25% of what was remaining, what was there in the soil, only 25% came out, hectare meter. So if I multiply 1400 into 0.25, that comes out to be 350 hectare meter. So this is Vd. So by this I can understand that if ground with the porosity of 0.4, if the ground is having 1400 hectare meter water, the soil, we can drain only 350 hectare meter. This is what the numerical is saying. So I hope you guys got the idea. Now we will go to new topic, which is where is groundwater actually stored? I mean, we are just draining it out from the ground. That means in ground it was stored somewhere, right? So where it was actually stored? So we have some things which we call as aquifers, Aquiclude, Aquitard. So where the water is stored. So the very first thing is aquifer. So aquifer is nothing but it's a rock formation. What's this? It's rock formation that stores and transmits groundwater. Here we can see this is what aquifer is. It is water bearing layer. So aquifer are the geological formation. First of all, it's naturally formed. These are highly porous, बहुत porous, highly porous and highly permeable. Alright, so aquifers are very highly porous, very highly permeable. That means it stores water and we can also remove or gain water from it, right? So it's highly porous, highly permeable. Example, we can say that let's say yeah, it's sand. Sand is highly porous, highly permeable. Sand, both type of sands, fine as well and coarse as well. Okay, so these are uh, what aquifers are. Now we have three type of aquifers. So these are unconfined aquifer, confined aquifer, and purged aquifer. Now what's that? So in unconfined aquifer, the upper surface that is fully saturated will be water table only. And so we can directly get water from it. There will be no artificial pressure. Artificial pressure means if it is like if there is any impermeable layer above, then it will create pressure on it. But above there is no impermeable layer above it. It's just the water table that's becoming its upper boundary. So it's unconfined. That means its upper boundary is permeable, so we call it unconfined. It is not confined from any, like from upper side meaning. But confined aquifer is the one which is confined or held from both the side. There will be a impermeable layer on the top also. So so water table will not be on the top of it. It will be an impermeable layer. So if there is impermeable layer, there will be artificial pressure on this type of storage uh, water that is stored in it. So it is confined aquifer. Now what's purged aquifer? So even if we have confined aquifer or unconfined aquifer, simply let's say we have unconfined aquifer. In between that, like in between the aquifer, if there comes a impermeable layer, then we call it as purged aquifer. So it will be semi-permeable, and there will be porous medium, but in between that there will be unconfined impermeable layer. Okay, so these are the type of aquifers that are there. Now we have, next is Aquiclude. Now Aquiclude is nothing but these are the type of geological formation which are highly porous. These are very highly porous, but it's impermeable. That means highly porous but impermeable. So if it is porous, even if water is there inside it, it's impermeable. That means we can't drain the water from it. So these are known as aquicludes. These will be very porous. Water can come inside, but water can stay inside, but water cannot flow from this. So so we can't use aquicludes that much. So aquiclude is basically clay layers, right? So clay is what? Clay is very highly porous, but it's, if water comes from, we can't just simply drain the water from it, so it's impermeable. So clay is one of the best example for aquicludes. That means water can be stored but it cannot transmit, right? So this is what aquiclude is. And here you can see here you can see confined aquifer. Upper layer can be there is no impermeable layer above this, so it is unconfined. If water comes here, it can be drained easily, right? Confined, at above you can see there is a impermeable layer, so it is confined. Now we see what's Aquitard. So Aquitard is nothing but, these are also geological formations, but simply the thing will be there. These are porous but low porous. So porosity is there. Porosity is there, but it's low. Even permeability is there. but it is also very low. Okay, so if we come if we compare it to aquicludes, aquicludes are very highly porous, but aquitards are less porous, and it is permeable, but it is also very less permeable. So what happens here, the water can seep, water can flow, but it flows very slowly. So water is stored in aquiclude, it was not at all able to move, but in aquitard it moves, but it moves very slowly. So for the these are semi-permeable layer. That means it can water can pass, but will pass very slow. So for this, best example is uh, sandy clays, which has property of clay and which has property of sand as well. So water can pass, but it will pass very slowly. So this is what aquitard is. Porosity is there, permeability is there, but both are very low. Now we have Aquifuge. So Aquifuge is the layer which is having zero porosity. So porous, no. Permeable, no. Zero porosity, it will not even transmit water, and it doesn't have water. Then how will it transmit? So it's not at all porous, and it will not be permeable hence. So these are aquifuge, we call it as aquifuge. Best example is granite. you know we use granite as our kitchen tops. So why is that used? Because if anything falls on it, it doesn't seep into the granite, so granite remains uh, how it looks for years and years. So that's why we use granite. We don't use cement, we don't use wood, we can't use any other thing, because the in kitchens there are so many kind of spices and staining things which can stain the table and the kitchen top. So we use granite because it's zero porous, zero permeable. So this is how, here you can see, these are igneous rocks, granite. Can't store water, can't transmit water. So neither stores nor transmits. So it is aquifuge. Okay. So these are what? Aquifers, Aquiclude, Aquitard, Aquifuge. I hope you understand now, and you understand the difference between them. You can differentiate between them with the two parameters, porosity and permeability, and you can just remember one example of all. Okay, so this is what the thing is. Now we see a comparison. So does aquifer store water? Yes. Does it transmit? Yes. Does Aquitard stores water? Yes. Does it transmit? Yes, but slow. Does Aquiclude store water? Yeah. Does it transmit? No. So, no. Aquifuge store water? No. Transmit? No. You just simply remember. Aquitard. Tard. Tard is from retard. Retard is nothing, slow. Okay. Aquiclude. Clude comes to close. So it's closed. It has water, but it's closed. It doesn't transmit. Aquifuge. Fuge means freeze. Let's say, so freeze. These are the remembering tricks. So it is freeze. That means there is no storage, no transmission. So this is what the comparison is. So I have one question for you, that why are tube wells drilled inside aquifer? Just think that. Now I guess you guys know the answer. Why we don't drill it into aquicludes, why we don't drill it into aquitards, and why even we don't drill it into aquifuge. Can you just write it into the comments, like why we are only drilling tube wells to aquifers, not to other geological formations. I guess you guys are now able to understand that. So tell me into the comments. I will not answer this. I just want answer of this from you guys. Now, there are some common mistakes that people do. They think Aquiclude is equal to Aquifuge. It's not. Specific yield is nothing but porosity. Porosity is how much water will be stored, but specific yield is how much will be drained by gravity. So that these both things are not same, right? And Aquitard and Aquiclude. People get confused between Aquiclude, Aquifuge, Aquitard. We just have to like make a little concentration or attention for this. Now, in this lecture, we studied what specific yield, what specific retention. We know that aquifer, aquitard, aquiclude, aquifuge. Now, I guess you guys are fully understood about the topics that we discussed today. If you have any doubt, you can ask me in comments, or you can leave me uh, a ping. I can answer on that. And yeah, in next lecture we'll be discussing what's spring, what's infiltration gallery, what's infiltration well, what's open well, what's tube well. So these are the topics which are going to come into the coming sections. So I guess you guys understood today's lecture. Let's meet into the next one. Thank you.